Okay, so we're going to talk a little bit about the absolute value, purpose of the absolute value function. First of all, using a generic example, we see that sometimes when you use the absolute value function, it looks like it's not doing anything. So for example, if I was going to take the absolute value of 3, I know that the answer to that is just a 3. However, if we take something like the absolute value of negative 3, we know that the answer here will come out as a positive 3. But the question is why? What is it that turns this negative 3 into a positive 3? So the operation we're using here to turn a negative into a positive is to multiply by negative 1. The reason we do that is because that lets us change the sign on the number, but not the magnitude or the size of the number. So by taking the absolute value of negative 3, we're really multiplying by negative 1, changing it into a positive 3. So this is really the reason why whenever we're solving problems that have absolute value signs, we need to consider two cases, because the answers here look the same. So how do we know where it came from? Did this 3 come from a positive 3, or did this 3 come from an original negative 3? We don't know. So we always have two cases when we're solving absolute values. So if you have an expression like this, the absolute value of x plus 5 is less than 10, I want to break this down into two different cases. Case 1, the number here inside the absolute value was already going to be positive. And if that was the case, we don't really even need the absolute value signs. So in the next line, I can pretend that they weren't even there. That number was going to be positive, so I don't actually have to change anything at all. I can just finish solving. And I do that by carrying over the 5 and arriving at x is less than 5 as my expression for my solution here. What I also have to consider, though, is that this x plus 5 was going to be a negative number. And if it was going to be negative, we have to change it. So just like I did with the negative 3, in order to make this expression the opposite sign of what it was, I multiply it by negative 1. And by doing that, I can consider the other case happening here. So if that is how I write my expression, I continue solving, bring over the minus 5 this time, meaning I add it on the other side to get 15. And then to isolate for x, I divide both sides by negative 1. The other trick here you have to remember is that when you divide by a negative or multiply by a negative, it changes the direction of the inequality. So I really get x is greater than negative 15 for my solution from case number 2. So what that means is both of these answers, both of these solutions have to be true when solving this case. So I write them both, that not only does x have to be greater than negative 15, but it also has to be less than 5. So I have a window of values that will make this expression true. And you can always test to see if you're correct by picking one of these values. So let's say I want to see if I'm right. What falls in this range of values? Let's test negative 1. That is definitely bigger than negative 15 and less than 5. So if I take negative 1 and I plug it in for x into my original problem, does this statement stay true? So negative 1 plus 5 is 4. Absolute value of 4 less than 10. Yes, definitely 4 less than 10. So it's a good sign that what I've done here in making both of these cases gives me the set of solutions that will make that statement true. So that is my solution for the problem that we worked on here.